Okay, so this problem is number 17. It has 5x squared plus x over x squared plus 9. It's asking about the domain. There's two ways to go about it. The normal way, which we've been doing, is set your denominator equal to 0. And so if you do x squared plus 9 equals 0, then x squared is negative 9. And so that'd be x is plus and minus 3i, basically. So it's imaginary, and so that means there is no vertical asymptote. So what I would expect when I graph it is it would be all real numbers. I'd like to verify that in the graph. So what I do is new document, add graph, and then we have 5x squared plus x in my numerator, and then my denominator has x squared plus 9. Okay, so that looks like that, and sure enough, there's no vertical asymptotes anywhere, and so this is all real numbers. Also, you might be able to notice if you have 5x squared divided by x squared that you'd have a horizontal asymptote at 5, and so that's why it levels out that way. But this one, the answer choice is just B for all real numbers. And it's because when you set your denominator equal to 0, you get an imaginary number. Because, again, x is the square root of negative 9, which you could break down into the square root of negative 1 times square root of 9, so that's I times 3. So there's your imaginary. I times 3 is the same as the 3i. Any questions? Okay. Then the last one. This one says use the graph to find the following, the domain and range. So this one looks like, based on the graph given, we know the domain would be everything except for negative 3 and positive 3 from the graph. You're not given an equation. This is one you have to analyze the graph. So this would be all reals x naught plus and minus 3.
Plus and minus for the domain?
X naught plus and minus 3.
I know.
Yeah. Or if you'd rather write it as x naught negative 3, x naught 3, that's fine too. Okay. So that's your domain. Then the range would be everything except for y equal 3. Bless you.
Thank you.
For that part, it's below 3, and it's also like a minimum. Like, I guess I'm going to describe this as a local minimum right there at negative 2. And so what we have is all y values that are below 3. So we're going to say y less than negative 3. And also greater than or equal to negative 2. Greater than or equal to negative 2. So don't just put not equal to 3, because that graph that I pointed out doesn't match the not equal to. What? Oh, the other way? Okay. Sure. Sometimes when I say move something up, they mean move the paper up, and then sometimes they mean like make the top part of the paper show. So it just depends on the person's perspective. Okay, so basically it's x naught negative 3, x naught 3, and y less than negative 3, y greater than or equal to negative 2. Okay, so now find the x-intercepts. if there are any. And it says to round to 1 decimal place. So this is a step that may be a little confusing. If we see that -3 is there and -2 is there, it's about -2.5, but it's a little closer to the right. But that's just like estimating it. So I think what I would do is I would try to create the equation first and then find the x-intercept. Let's see how that works. Okay, so if we create the equation, you'd have your denominator equal to 0, which would have to be x squared minus 9. And for your numerator, okay, so if we have this should be -3, by the way, sorry about that, y equal -3 right there. We have a horizontal asymptote at y equal -3, and so I would think of this as being possibly -3 x squared, because we know that when we have when we have a horizontal asymptote that's not 0, that there would have to be a ratio of some sort. Now that's probably not exactly what we want, just kind of working backwards a little bit on this. And I may need to view an example for this particular one. Let's graph this. We have -3 x squared divided by parentheses x squared minus 9. Okay, well that's somewhat close. Now I know I need to shift this down by 2. So to shift it down by 2, I'd say put -2 over here. Now the problem is about the width of the graph, because the problem is, like on the calculator, the x-intercept is at -2, but this looks like -2.5 or -2.4. So to affect the width of the graph, I'm going to pause the video for a moment. Okay, so after a little bit of thought, we don't need to really get the equation, because that's not really working out as far as like figuring out what the x-intercept is that way, because we have to have -3 here in order to make your horizontal asymptote correct, and you have to have x squared minus 9 because of making the vertical asymptote right. I did notice that I had to put a -2 over here for a vertical shift down in order for that to happen too. But beyond that, it's one of those things where it accepts a range of numbers. Like it would accept basically plus and minus 2.5, or it would accept plus and minus 2.4, or it would accept plus and minus 2.6. So when you're doing this electronically on MathXL, you need to push the button to zoom in and look to see like what tick mark it's at. So that would be how you go about that problem.
Is there going to be a question that?
I'll have to look at that and see if I could separate that one part or not. So that's still to be decided. Okay. So then for the y-intercept, we know the y-intercept is at -2. And for the horizontal asymptote, we know that's at -3. And for the vertical asymptote, that's at plus and minus 3. And there's no tilted line, so there's no oblique asymptote. So that's the B choice. Yeah. Okay. So that's the end of the review now. And I'll stop the video, and then we can talk some more if anybody has individual questions or something. So, anyway, there we go.